Right, so we've got to show that this equation has got no real roots. Now the roots is another term for the solutions to the equation. So the values of x that will put the left hand side of that equation equal to 0. Now you should remember that this is a quadratic equation, so remember that there's a formula for finding the roots of a quadratic, and if we've got a quadratic in the form ax squared plus bx plus c equals 0, kind of a general form, then remember that x will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now that's the quadratic formula. Now the thing about this is we've got a square root here, and inside the square root there's this b squared minus 4ac term. Now if you try and take the square root of a negative number, your calculator will tell you math error, and we can't do it. We can't do it unless we start using complex numbers, which you might do if you go on to do further maths. But for the moment, we have to say that if b squared minus 4ac is negative, that means there aren't any solutions to that quadratic equation, or in other words, there are no roots or no real roots. Now, roots which are not real we call imaginary or complex roots, and they will involve the square roots of negative numbers. But if there's no real roots, that means b squared minus 4ac must be less than 0. So what we can do with questions like this is we can say, no real roots means b squared minus 4ac must be less than 0. If it's equal to 0, by the way, if this here is equal to 0, then that's okay, because the square root of 0 is 0, and that means we just get one root, minus b over 2a. And what that actually means is that if we think about what the graph of the function will look like, if we try and draw a graph, so if we have this and then we say that's x, oh god, sugar, let me get rid of that. Okay, and then we say that that's x and that's y. Supposing, I mean, we don't know, but supposing k is positive, so we know it's a smiley face kind of shape. If it looks like that, then you can see that because the curve never actually comes down and crosses the x-axis, that means that the y value is never equal to 0. So this curve here, whatever its equation is, this curve here will have no real roots. If it looks like this, then yes, it will have real roots. There, where y equals 0, and there, where y equals 0. If it looks like that, just kind of sitting on the x-axis, then that's the situation that you have when b squared minus 4ac is equal to 0, so you only end up with one root, and that's minus b over 2a. So in this situation here, we have b squared minus 4ac is less than 0. In this situation here, we have b squared minus 4ac equals 0, and in this situation here, we have two real roots, b squared minus 4ac greater than 0. Now we want it to have no real roots, so we want the condition b squared minus 4ac is less than 0. Now our b here is the coefficient of x, which is 4k. So we've got 4k squared minus 4. Now a here is the coefficient of x squared, which is k, and c is the number here, which is 3. If we multiply this out, 4k all squared is 16k squared, minus, and then it doesn't matter what order you multiply things in, so that's 4 times 3 times k, which is 12k. Okay, so we've got an equation here. If we take out the k, we get k's into 16k minus 12. Okay, and we can also take out 4, so we go 4k into 4k minus 3. And we want that to be less than 0. Right, so let's think about this. This is an inequality. Now, how do we solve this? Well, we solve this by putting it equal to 0, and then when we solve that, we'll find what we call the critical values. Okay, so put it equal to 0 and you'll see that either this bracket here must be equal to 0, in which case k is 0, or this bracket here must be 0, in which case k equals 3/4. But we don't want it to be equal to 0. We don't want 4k brackets 4k minus 3 to be equal to 0. We want it to be less than 0. So we're looking for a range of values that are going to have these values of k determining the range. The easiest way to think about this actually is to kind of draw another graph. So if I sketch another graph, then imagine that these are our values of k here, and here we've got our 16k squared minus 12k, and what we want to find when this here, which is our b squared minus 4ac, we want to find when that is less than 0. So if we can sketch what this looks like, we can find where it goes below the x-axis, and those will be the range of values which will give us a negative value for b squared minus 4ac. So we know that it crosses the axis when it equals 0, so when k is 0 or when k is 3/4. Now it's a positive, so it's going to look something like that. That's 0, that's 3/4. So in other words, b squared minus 4ac, which is this thing here, which is this b squared minus 4ac, that is going to be for values of k that go from 0 to 3/4. Okay, but there's a little adjustment we need to make, and if we look at the original function kx squared plus 4k plus 3, then you'll see that if we put k equal to 0, we're going to get 0. Let me see if I can highlight it. We're going to get 0 when k is 0, plus 0 plus 3 equals 0. Well, that is obviously nonsense. It doesn't make sense. So not only does k have to be between 0 and 3/4, it can't be equal to 0 if there are to be roots. So for there to be no roots, we want k to be either equal to 0 or any value between 0 and 3/4. And that's the final answer.